Alright, so let's look at how we use simultaneous equations, applications of simultaneous equations. So, a bakery produces two types of bread, wholemeal and rye. The respective processing times for each batch on the dough making machine are 12 minutes and 15 minutes, while the oven baking times are 16 minutes and 12 minutes respectively. Remember that when you have respectively, that means basically in order. So with wholemeal and rye, the dough making, that's wholemeal, 12 minutes, rye, 15. With this oven baking, it's wholemeal, 16, rye, 12. How many batches of each type of bread should be processed in an 8-hour shift so that both dough making machines and ovens are fully occupied? So we're wanting to make sure that those machines are used all the time throughout that 8-hour shift, so we are making as many batches of bread as we can. So we want to find the optimal number of batches of bread to make in an 8-hour shift. So we're going to use X to represent the number of batches of wholemeal and Y to represent the number of batches of rye that we can make. So here I've written out this information as simultaneous equations. Let's go through how I constructed those. So I've got 12 for the first part, the dough making. This dough making, it's 12 minutes for wholemeal. Okay, so that's 12 with her wholemeal, and it's 15 minutes for the rye. Okay, with the Y there. And 480, well, that's 8 times 60, so that's 480 minutes. All right, I'm working in minutes here rather than hours. So this second line has got to do with the oven baking. So 16 minutes for the wholemeal, 12 minutes for the rye over 8 hours. So both of them added up have to make up 8 hours. Same with the dough making machine. They both have to add up to make 8 hours. So they're my simultaneous equations. So let's put that in matrix form, and that's the usual way that we sort of would represent this. That we'd represent the pronumeral matrix as X. We'd usually call it X. Okay, so here we've got A times X equals to B, where B is that answer matrix. All right, so going through how we figure it out, we apply the inverse of A to undo the effect of A, and I've got to do it to both sides of the equal sign. Remembering, I do it on the left-hand side of A times X, so that means I've got to do it on the left-hand side of B. So I'm left with X equals the inverse of A times by B. Now here I've done it by hand. Where I've figured out the inverse of A. You can see, well, it's a bit hard to see. I would have flipped those and times the C and the B by -1. That's my determinant, and times it by B to then figure it out. But of course, we can do that on our CAS calculator, which I'm sure a lot of you will end up doing. So you can see I've popped them in and assigned them to the variable. And then I've gone, okay, inverse of A times by B gives me 15, 20, that matrix there. I can also use my solve using the variables that I've declared to find x and y, and then it solves it for us. Now, if you're asked for something like this, you can't just give the matrix unless they ask for a matrix. You've got to then extract the information and say what it is. So here, to fully optimize the equipment during an 8-hour shift, 15 batches of wholemeal and 20 batches of rye should be made. Okay, so I've got now some past exam questions. So here is from 2017, exam 2. So that's extended response. So this was the first one in that module. The school canteen sells pies, rolls and sandwiches. The number of each item sold over 3 weeks of school is shown in matrix M. So you can see we've got pies, rolls, sandwiches, week 1, week 2, week 3. All right. In total, how many sandwiches were sold in these 3 weeks? So we need to think about how many sandwiches were sold in the 3 weeks, over the whole 3 weeks. So a few ways we can do it. I might just go 60 plus 43, that's 103, plus 56, that's 159. Okay, looking at the past exam, 89% of the state got that mark, 11% got 0. A few students just gave 56 as their answer, which was the number sold in week 3. So obviously these students didn't read these properly. They just read it in week 3, but it doesn't say that, does it? In these 3 weeks. So that's all of the 3 weeks. Okay, so the element in row I and column J of matrix M is Mij. So what does element M12 indicate? So that is row 1, column 2. So that is the number of rolls sold in week 1. Which was 24. Okay. 75% of the state got a mark there, 25% said 0. Some students only put 24, which isn't really a complete answer. It's not asking you what is that element. It's asking, what does that element indicate? What does it mean? It means the number of rolls sold in week 1. All right. So let's now look at this matrix equation. So we have here this matrix equation. We've got A, B, and C, and all of this. Okay, so A is the cost of 1 pie. B is the cost of 1 roll. C is the cost of 1 sandwich. Now that is matrix M, isn't it? That's the numbers of each item. So this matrix, let's call it X, is, the individual cost of each of these items. Okay, but we don't know that yet. They're just indicated by those by those pronumerals. So how are we going to figure out what is the cost of one sandwich? We are going to use our matrix knowledge. Okay, I'm going to X are 3 by 3, okay. Put them in, 35, tab, 24, tab, 60, tab. I'm going to put it all into my CAS calculator so I can do my calculations on it. I cannot do, well, I don't know how to do an inverse of a 3 by 3 matrix. It's something you don't need to know how to do by hand. It's something we can just do on our CAS calculator. Okay, so I'll also put in the last one. There's 3 rows and 1 column, which is showing how much money we would have made that week, isn't it? So 491.55, 428. I'll put the zeros in so my calculator gives me decimal answers. 48760, and let's just call that B. Okay, just coming back here for a second. You can see this last matrix, what it is, what that $491.55 is saying. It's saying, okay, in week 1, we sold 35 pies for that amount, plus 24 rolls for that amount, plus 60 sandwiches for that amount, and all added up together, we got $491.55 in week 1. All right. So we'll go back here. So inverse. So -1 times by matrix B. All right. So we get a matrix here of 465, 420, and $3.80. So our cost of one sandwich is $3.80. So that is 56% of the state got 1 mark there. So yes, you can see that I extracted the information from that matrix. I didn't give the whole matrix as the answer because that's not what the question is asking. It's only asking for the cost of one sandwich. All right. So the matrix equation below shows the total value of all the rolls and sandwiches sold in these 3 weeks is $915.60. So all rolls and sandwiches. All right, so it's not including the pies, is it? It's not including the pies. So we get shown this L times by that amount is $915.60. Right, matrix L in this equation, matrix L in this equation is of order 1 by 3. All right, so it's a row matrix with 3 columns. write down matrix L. Okay, so this is an interesting one. So we want to be able to have a matrix which is going to add up all the rolls and the sandwiches, but not add up the pies. Not add the pies. And we want it as a 1/3. Now, why is that the answer? Now, if you think about it, if you remember our matrix multiplication, we times the row by the columns. All right? So because I've put that first element in this row as a 0, that means that that's 0 times by that is 0 plus 1 times by 428 plus 1 times 487.60. Then it all will equal up to that. So because I've put that 0 there, it's not going to add up that one, is it? It's only adding up these two. Now, this had to be a 1/3. A very common mistake was students gave a 3/1 matrix. A 3/1 matrix. But that couldn't work, can it? Because you wouldn't be able to do that multiplication. Now also, we end up with a 1/1 matrix. That means that L had to be a 1/3 in order for us to get that proper matrix there. Okay, that's why that had to be a 1/3. So this matrix, when you times it by that, it effectively only adds up these two. It doesn't add up that one. All right, so let's look at this one from the 2018 Northern Hemisphere exam, exam 2. There are 3 farmers, A, B and C. They each placed orders for 3 types of fertilizers for their cornfields. The types of fertilizers are CALM, Nitro and Fate. K, N and P. The matrix below shows the amount of fertilizer in tonnes ordered by farmer A and farmer B. So you can see there's farmer A there and farmer B. So farmer A ordered 2 tonnes of CALM, 4 tonnes of Nitro and 2 tonnes of Fate. Farmer A and farmer B each paid a total of $16,000 for fertilizer. Each paid a total of it. What conclusion can be drawn about the prices of Nitro and Fate? All right. So they've bought different quantities of things, but they've each ended up paying $16,000. So we've got Nitro and Fate here. Nitro and Fate. You can see that together I've bought 6 tonnes of that farmer A has bought 6 tonnes of Nitro and Fate. Farmer B has bought 6 tonnes of Nitro and Fate. So even though they've bought them in different ratios, so farmer A's bought 4 and 2, farmer B's bought 5 and 1, they've each bought 6 tonnes altogether of nitro and fate. So that means that they're actually the same price. And fate are the same price. Okay, because they've bought 6 tonnes of it, of both of them, and they've ended up paying the same amount because they both bought the 2 tonnes of that K. All right, so let X be the price per tonne of calm, Y be the price per tonne of nitro, Z be the price per tonne of fate. The total cost of these 2 orders can be summarised by the matrix equation. Okay, so you can see, all right, this is the tonnes of each one, so they'd be the individual price, 16,000, 16,000. Explain why this equation cannot be solved using the matrix inverse method. Why can't we solve it finding the inverse of that? We can't find it because it's not a square matrix. Okay? We need a 3 by 3 matrix to find an inverse as only square matrices have an inverse. Okay, so that's why we can't use the method we've been using to solve that. So what do we do? What do we do? They've done this. The matrix equation below shows the fertilizer orders for 3 farmers. Okay? So now we're including C. First off, we're only talking about A and B. Now we're going to be talking about farmer C also. You can see he or she has bought 1 tonne of each of the fertilizers. Okay, so now we could solve this. Okay, so complete the matrix equation below by filling in the missing elements. Alrighty, let's get to my CAS. So, yeah, 3 by 3. And so 2, 4. What I'm doing now is I'm putting in the original matrix because I need to find its inverse, don't I? Okay, I'm going to store that. Did that one get a name? It didn't get a name. I might just leave it for the moment and then to the -1. Oh, it's all fractionals. Let's go up, grab that down and go Control equals, there we go, that looks a bit nicer. So -2, 1, 3. Okay. Yep, and that's what you're expected to answer here. So, determine the cost in dollars of 1 tonne of fate. 1 tonne of fate. So, we have to solve that for fate, which is Z. All right. So, let's grab that one, and it is times by a 3 by 1 matrix. So 16,000, 16,000, and 6,500. Okay, to give us the matrix 3,500, 3,500, 500, 500. Okay. All right. So 1 tonne of fate is $1,500. Now that's what would get you the mark, not the matrix, because you have to, as I said, extract the information from there. Okay.